Hello, everyone. How you guys doing today? Today we're going to be talking about another aspect of gravimetry. This both involve calculations and theoretical aspect. Now we're going to be taking it bit by bit, even as we talk about questions under gravimetry. For those of you meeting for the first time, my name is Adrenaline, the Bazooka Prophet, your chemist. Now, over time, we have helped a lot of students to master chemistry and sciences in a very robust way. We have we have credible evidence. We have track records of our students all over the world, in the United States, in in Australia, in Sweden, in India, in Saudi Arabia. We've helped a lot of students who have bad background in sciences to become a pro in just few hours sections with us. Of course, we are good at what we do. Now, in this particular video, we're going to be talking about some questions here, which says dash is best for filtering precipitates of large crystals, such as those of magnesium ammonium phosphate. And you are given different kinds of filter paper, starting from Wattman number 42 filter paper. We have Wattman number 41 filter paper. We have Wattman number 40 filter paper, and the Wattman number 51 filter paper. Now, all these are used to filter our precipitate during gravimetric analysis. Is that understood? Now, to actually understand the best filter paper used, right, we need to understand what each of these filter paper are used for, right? Not all filter paper are used to filter precipitate. For example, in filtering of very fine particles or very fine precipitate, we make use of Wattman number 42, right? They are of different sizes and grade. While in filtering small crystalline particles or precipitate, we use Wattman number 40. But in filtering gelatinous precipitate and large crystals, such as magnesium ammonium phosphate, we make use of Wattman number 41. And that gives us our answer to be what now? B. But the one we make use in our laboratory, or the one that schools always provide for you, is Wattman number 1. I guess you might just be hearing this for the first time. So let's quickly rush to the next questions. Let's go deeper to understand how we can talk about this other question. Now, look at this question deeply under gravimetry. The question says the tolerance for mercury in foods set by a regulatory body is 0.5 ppm. And what does ppm stands for? Part per million. And 1 ppm is equivalent to 1 milligram per kilogram. They now said a 113-gram sample of fish, right, taken from a river in the region is found by indirect analysis to contain 0.11 milligram of mercury. Wow. That's something to talk about. By what value does the mercury content of the fish exceed that of the regulatory body? Be very, very careful. This question is actually very, very simple. I can tell you for a fact. You see why I'm smiling? Because it's very easy. It's very easy. But we focus on why we are doing it. We focus. Okay, let's go back. Okay, let's talk about it. Now, we already have our standard to be this. Look at it. 0.5 milligram per what now? Per kilogram. Simple. So what do I do? I already have this one here, which is 0.11 milligram. So I will have to convert this my 113 gram to kilogram, right? Which when I divide this one by 1,000, right, I'll be having it to be 0.113 kilogram. So when I divide it, you find out that it is very, very simple, right? So I divide it like this, which is okay, 0.11 divided by 0.113. Okay, it gives me 0.973. 0. Okay, let me write it here. So 0.973 milligram per kilogram. This was what I got as the part per million, right? As the milligram per kg for the fish mercury determination. They're not asking you, by what value does the mercury content of the fish exceed that of the regulatory body? Since I have this one here, we are not looking by how much does it exceed. It's very simple. So you just come here to say it will exceed by, you just say 0.973 minus what now? This standard here. But this is the standard. This was what you got. So by what amount does it exceed? So here becomes 0.5, which when I subtract again with my calculator, the answer becomes 0.47. 0.473. 0.473 milligram per kg. So it will exceed by this amount. And that is how easy this part is. So thank you and God bless you. Please don't forget to like, share, comment. And remember, we are having a marathon live Zoom classes. For you to actually enroll in these classes, please do well to contact me via this number. The fee for the class per hour is very, very affordable. Very, very affordable. Why waste time? Send a DM now. Thank you guys and God bless you. Shalom.